Hi, in this lecture we will learn about implicit differentiations. What is implicit differentiation? It is whenever we cannot express the functions in the form of y as the subject and x term on the right side. For example, the one that I show here. You cannot write y as the subject. The formula is whenever we want to differentiate y with respect to x, then we have to write dy over dx. What if the function that we want to differentiate is y to the power of n? Then we just have to differentiate that y to the power of n as usual, bring n to the front, and then just write y, subtract 1 with the power. After that, since this is not in terms of x, then we have to write dy of dx behind it. This is actually by using chain rule. Let's look at example 1. Find dy dx in terms of x and y. So, look at the question. We want to differentiate with respect to x. So, can we write this function a as y as the subject? Well, try it out. You can bring 6x to the right side, and then to eliminate that power 3, you can just cube root the whole thing on the right side. You can also change it to power 1 over 3. This is not an implicit function because you can write y as a subject. So to differentiate this, you can differentiate this as usual. Bring the power to the front, use power rule. Next, just copy the function, subtract 1 with the power. You get negative 2 over 3. After that, just differentiate the terms in the bracket. You differentiate it, you get 2x minus 6. Rearrange your answers. Now the numerator is just 2x minus 6. This term has power negative, so bring it down with the power 2 over 3. And now there's a 3 at the denominator as well. And that's your answer. Let me show you how to differentiate this if you want to use implicit differentiation. To solve this implicitly, you have to differentiate all of the terms with respect to x. So I'm going to write d over dx in front of each of the terms. Next, I will differentiate this one by one. Start by the first term. This first term is d over dx of y cubed. I have to differentiate y cubed with respect to x. But this is in terms of y, it's not in terms of x. So to show you the concept, we have to use chain rule to apply this formula. Let me let u as y cubed so that it's easier for you to see. So now the problem is to differentiate the u. If I let this as u. Okay? Next, by using chain rule, what we have to remember for the formula is copy the denominator and the numerator. After that, combine them with one unknown. And that one unknown would be, since we are using the variable y here, so we just write dy. Next, we can differentiate du in terms of dy. So du over dy is just 3y squared. After that, you can replace your formula. Du over dy is just 3y squared multiplied with dy over dx. Since we don't know what is dy over dx, because there is no y in terms of x, so our final answer for d over dx is just 3y squared times dy over dx. So just replace this as 3y squared multiplied with dy over dx. Next, just differentiate the other terms. This is 6x with respect to x. So we can just differentiate 6x as usual. Differentiate it, you get 6. Differentiate x squared, you will get 2x. The question wants you to find dy over dx in terms of x and y. So this is our dy over dx. We have to leave it as the subject on the left side. So start by taking everything else to the right side, and then just divide this 3y squared term to the right side. And that's your answer. Well, is the answer the same as the one that we have found without using implicit differentiation? Actually, it is the same. It's just in the different form. If you try to substitute y with this definition, then you will get exactly the same as method 1 answer. Now, let's look at example 1b. How to differentiate this? Start by writing d over dx in front of each of the terms. It is useful to remind us that we want to differentiate with respect to x. So if the term is not in terms of x, for example it's in y, then we have to use chain rule, or just apply the formula which has dy over dx behind it. Look at the first term. We want to differentiate 3y squared in terms of x. So this is not in the same term. What do we have to do next? Well, simply just differentiate 3y squared as usual. So bring 2 to the front, multiply with 3, you get 6y power 1. After that, just multiply it with your dy over dx. Why? Because of the chain rule that I have explained in example 1a. You don't have to write your chain rule steps. You can immediately write your answers like this. Next, we want to differentiate to y. This is in terms of y. It's not in terms of x. So, remember, since it's not in terms of x, you have to multiply with dy over dx. But you have to differentiate this to y as usual. So differentiate to y, you will get 2, because y power 1, when you bring it to the front, is just 2 multiplied with 1, and then 1 minus 1 power y power 0 is just 1. Next, we have xy. Differentiate xy in terms of x. We have x term and y term at once here. But what is the operation in the middle? The operation in the middle is multiplication. So to solve this, you have to use product rule. Product rule because the operation in the middle is multiplication, and we have two variables. Y is not a constant, y is also a variable. X is also a variable, the unknown that we want to differentiate. So u is x and v is y. After that, you differentiate your u and also your v. Differentiate u with respect to x, what you get is 1. Differentiate v with respect to x, here, this is y. So remember, whenever it's y, you have to differentiate y as usual. Differentiate y power 1, you just get 1. After that, don't forget, you have to multiply with dy over dx. Why? Because we want to differentiate with respect to x. But now, this is in terms of y. Y is not a constant. That's why we have to differentiate y as usual. After that, multiply with dy over dx according to the chain rule that we have discussed in example 1a. Next, this is product rule, so remember your crossfish formula. So according to the formula, this is just y multiplied with u prime, which is du over dx, 1, plus with your u, which is x, multiplied with the dv over dx, which is just dy over dx. Next, we want to differentiate x cubed in terms of x. Well, this is just x, so it's the same term as what we want to differentiate it with. You don't have to do anything, just differentiate x cubed as usual, 3x squared. Nothing to be written behind because this is just in terms of x. You only write the terms behind like this if, let's say, it is not in the same term. Now, next thing that you have to do is we want to write dy over dx as the subject. We have a lot of dy over dx here. So what to do next is just to factorize that dy over dx. Factorize that dy over dx, write it in the front, and then leave everything else in the bracket. So you have 6y plus 2 plus with x. So the other terms which are not multiplied with dy over dx can be written on the right side of the equals sign. Now, this is just dy over dx multiplied with this whole term. So since we want dy over dx as the subject, we can bring everything else to the right side by dividing. So opposite of multiplication is just division. So your final answer would just be 6y plus 2 plus x at the denominator and 3x squared minus y at the numerator. Example 2. We want to find dy over dx for each of the following. Please focus on the denominator. Now we want to differentiate with respect to x. So write d over dx in front of each of the terms that you want to differentiate. After that, just differentiate the terms on the left side. So this is e to the power of x plus y. Remember your formula for e. When we want to differentiate e power of fx, any function, what you have to do is just copy the function exactly as it is. After that, multiply with the derivative of the function. Differentiate the function. Multiply with that exponential term. So do the same here. Same concept applies, no matter whether it is implicit function or not. So, start by copying your exponential term. Do not do anything with that exponential term. After that, multiply with the derivative of the power of that exponential term. And what is the power of the exponential term? It is just x plus y. You can stop until there because we have not differentiated this yet. So just leave it like that. Okay, next on the right side, this is just natural logarithmic function. Remember, to differentiate logarithmic function, the formula is to 1 over of the function. After that, differentiate with the function. Please always remember these two formulas. Apply it whenever you have exponential term to differentiate and also natural logarithmic form to differentiate. So now, for this natural log function, what is our function? The function is x times y. So this is our fx. According to the formula, you have to write 1 over the function fx. So write xy and then just differentiate that function xy. Now, next step, we have not differentiated the terms in the bracket. So the terms that we have differentiated, just copy it down. Now, focus on the terms that we have not differentiated. Differentiate x with respect to x. So it's in the same form. So to differentiate that, you will just get 1. Plus with, differentiate y in terms of x. This is not in the same term. Since it's not in the same term, remember what you have to do is just differentiating y, as always, you get 1, and then multiply it with dy over dx behind it. Same also on the right side, just copy the terms that doesn't have that d over dx term. After that, focus on differentiating that term in this bracket. So this is x times y. In the middle, there's the multiplication sign. So we have to use product rule for this question. Our u is x, our v is y. Differentiate u with respect to x. This is just x, so you get 1. Differentiate v with respect to x. What you get is just 1, but multiply with dy over dx. Why? Because it's not in the same term. Use product rule here. So using product rule, this is y multiplied with u prime plus u multiplied with v prime. Our final answer must be in the form of dy over dx equal to something. But now we have dy over dx here and also here. So what we have to do is, first we have to expand it. Open the bracket. After you have expanded, this is what you get. And then we want to factorize that dy over dx term. So move all of that dy over dx term to the left side and the rest to the right side. Next, factorize that dy over dx term. Notice that the term here, x divided with x times y, can be simplified. So you're left only with 1 over y. The same as the one on the right side. This is y divided with x times y. So you can cancel this off, and what's left is just 1 over x. Next, you can just leave dy over dx on the left side and bring everything else to the right side. This is just multiplication, so when you bring it to the right side, it will be division. Divide everything with this term. Now, just to tidy things up, what you can do is you can equate the denominators on top and also below. So on top, this is just e power x plus y over 1. So you have to multiply with x at the denominator and also at the numerator. Also the same as the one here. This is over 1, so we want to equate the denominator as y. So we have to multiply with y at the denominator and also y at the numerator. Next, this just means the terms on top divided with the terms below. So when you divide, you can change it to multiplication, and then the terms at the denominator will go up and at the numerator will go down. And lastly, just multiply this y with everything on the left side and multiply the x with everything on this right side. And that's your final answer. Now, how to differentiate example 2b? Remember, we want to differentiate dy over dx. So we want to find that term of dy over dx. So this means we have to differentiate with respect to d over dx. Write d over dx in front of each of the terms. Now, differentiate it one by one. To differentiate the first term, this is a combination of x and also y term. So since you want to differentiate with respect to x, we have to differentiate this by using quotient rule. Why? Because we have a fraction. Write your u and your v next to each other. Your u will be the numerator, your v is just the denominator. Differentiate u with respect to x is 1. Differentiate v with respect to x, what you get is, differentiate y as usual, you get 1. And then since this is not in the same term, so we have to write dy over dx behind it. Next, just substitute into the formula of quotient rule. Remember the formula? The crossfish with the I of negative and then over v squared. So this is vu prime minus uv prime over v squared. Writing v down, u prime minus v times with the v prime over with v squared. Next, differentiate x. This x is in the same term as the one that we want to differentiate. So just differentiate x, as usual, you get 1. Now, the other term is y. We want to differentiate it with respect to x. It's not in the same term. So if it's not in the same term, remember what we have to do is, behind it, there will definitely be dy over dx. In front it, it's just differentiating y. As usual, you get 1. After that, the next term is in terms of y. But we want to differentiate in terms of x. Remember, start by writing down your dy over dx term behind it, because you need to have that since we have different terms. Next, differentiate 4y squared as usual. So 4 times 2 is just 8, multiply with y power 1. Our final answer is to write in terms of dy over dx, but we have dy over dx everywhere in this line. So look at the first term of dy over dx. It has over y squared. So this over y squared can be eliminated by multiplying everything with y squared. So multiply each of the terms with y squared. For example, 1 multiply with y squared. And next we have multiply with y squared as well with that 1. Also multiply y squared with 8y. Find your dy over dx terms. Combine them together. Arrange them next to each other and then factorize it. bring all of the other terms to the right side. Now, all of the dy over dx terms is already on the left side, so we can just factorize it and leave everything else in one big bracket. The operation is multiplication, so when you bring all of that terms to the right side, it will be division. As you can see, there are too many negatives on top and also below, so what I can do next to simplify is just factorizing that negative sign. After you factorize the negative on top and also below, you can simplify and cancel that negative out, and the answer is just y cubed plus y on top and x plus y squared plus 8y cubed at the denominator. And that's your answer. Look at example 3. Find dx over dy of the equation. Look at the question carefully. The question here says that this is dx over dy, so we want to differentiate with respect to dy. Start by writing d over dy in front of each of the terms. Look at it one by one. First term is to differentiate 3y squared in terms of y. Do we have them in the same terms? Look at the colors. The color is green because both of them has the same variable. Only variable y here, and also we want to differentiate with respect to y. In this case, we don't have to write that dy over dx because we only write dy over dx behind it if we want to differentiate with a different term, different than the terms that we are differentiating. So for this case, just differentiate 3y squared as usual, 6y power 1, and then you don't have to write anything behind it because it's already in the same term. Look at the next term. This is 2y. We want to differentiate with respect to y. Both of them are already in the same term, so just differentiate to y as usual. You just get 2. Next, you want to differentiate x times y. There is a different term here, even though we are multiplying with y, but there's x here. There's another unknown there. And we want to differentiate both of them with respect to y. Look at the operation between them. The operation between them is just multiplication. So remember, when this is multiplication, we have to use product rule. So write what is your u and what is your v. Your u is x and v is y. Differentiate with respect to y. So this is in terms of x, but we want to differentiate with respect to y. What should be the answer? The answer is, we have to differentiate x as usual, you get 1, but since it is in the different form, so we have to write dx over dy behind it. What about the next term? This is just y. So when you differentiate y, what you get is just 1 with respect to y. It's in the same term, so you don't have to write dy over dx behind it. Next, remember your crossfish. So just write down the terms, starting with your v term multiplied with u prime, which is dx over dy, add it up with u times with the v prime. Next, you want to differentiate x cubed, but in terms of y. So it's not in the same term. If it's not in the same term, what you have to do is, you have to differentiate x cubed as usual to x squared, but don't forget to multiply it with, what should we write at the denominator is y, because we want to differentiate with respect to y, and what should we write at the denominator is x, because that's the term that we are differentiating. So this is actually chain rule. Next, we want to write in the terms of dx over dy. So we already have the terms of dx over dy, just arrange it. Now you can factorize that dy over dx term. Their operation is multiplication, so just divide everything to the right side. Similar to the previous example, we have lots of negatives in this answer, so we can also factorize that negative out, and then you can cancel out that negative. Make sure when you expand the negative, you will get exactly the same as before. Sorry, there was an error and I have corrected it. It should be dx over dy. This will be your final answer of dx over dy. Thank you for watching.